Okay, Angular schematics. How many here have used Angular schematics? All right. How many have used Angular CLI? Now that's all the hands that actually used Angular schematics. So Angular schematics is the secret sauce underneath Angular CLI. So now you know that. If someone says schematics, they try to be clever like me. Yes, I've used it. All right. So it is the unknown hero. I think this talk was well named, right? Most of you don't know that it's underneath. About me, my name is Christoffer Noring. As Sebastian was saying, author, not a baker. Well, you kind of understood the gist, I think. So, what is Angular schematics then? Well, I said it's the secret sauce of the CLI, right? But what it is, it's a workflow tool underneath Angular CLI. So that means, in short, it's going to help you with scaffolding, and it's going to help you to update your code. Every time you run an update of a major version of Angular, Schematics is there to make sure that it does the changes in the files that you need for your project to work. It could be different versions of different libraries. It could be code that we stick in or underneath a constructor. So it's really there to affect your code. That's what Schematics will do for you. Sorry, I'm a bit short of breath. I was running downstairs here, so my stamina is not good. We established that much. Okay, I said it was the secret sauce of the Angular CLI. There were some key moments in the creation of Schematics, whereas the Angular team thought we need something better than what we currently had, and they thought we need something easier. Ease of use was a key point for them. Extensibility, asynchronicity, and so on. So they thought about all these major factors. How do we create the best scaffolder, the best tool possible to affect code? End result is Schematics, and I think they're pretty happy with the end result. So one thing we need to establish about Schematics is how it affects things. Schematics affects things not directly, but indirectly. And what do I mean by that? Well, imagine that you have a file system, right? That file system has directories. Inside of those directories, you have files. So what Schematics does is to look at the file system, but it kind of creates a copy virtually in memory, and it calls that thing a tree. Okay? So every time you run a schematic, it runs an operation or a transform on a tree. So the tree can easily be translated into your actual file system, but it kind of does it virtually first to show you what's going to happen. So if you run your schematic with an instruction of saying, I'm going to add a file, it's going to add that file to the tree and not your actual file system, unless you actually run your schematic in production. So if you run your schematic in production, it will affect your file system. So you always have this sandboxed environment in which you can try things out. Okay, so installing the Schematics CLI is the first thing you're going to need to do when you work with Schematics, and that's as easy as doing a simple npm install. Once you have that, you will get an executable called Schematics. All right, so the first thing we're going to do here is actually create our own schematic and show how simple that is. So as I say, you install globally this Schematics thing, and you get this runnable file. So once you have this runnable file, Schematics, we call it. So we call it with the blank argument and the name of your Schematics. So this is pretty much like trying to generate a component or a project or whatever you're trying to do, right? But you're generating a Schematics project. This is the end result of you doing this. So in this case, we have called the schematic my service, and the end result here is a bunch of files. So you get the source, you get the my service, which is the name of your schematic, and you get a few interesting files. As you can see, it's not a lot of files. It's a test file, it's an index.ts, and it's a collection JSON. So 3 different files that are important. So index.ts is really where your rules live. Now, so a rule in schematics is simply a transform, and a transform is a change, right? So imagine that you have your tree, and you need to apply all these changes. So every change we're going to do, we call those a rule, right? So rule is simply a description of what you're trying to do, which can be updating a file, adding a file, and so on. Let's have a look at that. So this rule, right? So we have this function to start with. It returns something of type rule, and that thing has an options input, and we also have an inner function. We want to see code, right? We're developers. Yeah, a lot of slides, a lot of descriptions, but this is what it looks like. You're able to see this, right? You're awake, right? Great. Okay, so we're looking at a function that produces a function. Awesome, a function factory, right? But as I say, the external function here, my service, simply has an options parameter to it, and the options parameter is a representation of your command line. So if you gave it a bunch of arguments, that's going to be inside of options as an object. Now, that's the outer function. The inner function is simply something that returns a function, right? So looking at the inner function here, we see two different parameters. One being the tree, where we're going to do changes upon it, and the other one being a schematics context. Now, so this one doesn't actually do anything. It just returns the tree. So if we run this, our end result is nothing. Short word about collection JSON. This is just a manifest file that kind of tells you what's going on and what the entry point is for your schematic. There are a lot of information about what the schema is, but I'm going to skip that for now because I want you to have a good understanding of schematics and what you can do with it. All right. It goes a bit quickly. I have more slides than I have time, so excuse me a bit, right? So what I'm trying to do with my schematic is first off to build it, and the other one is to execute it. So I build it by calling npm run. That thing runs a TypeScript compiler, and the end result we can just invoke. So once we invoke that, we get something looking like this. It's going to tell us nothing will be done. And I'm done here. No, I'm just kidding. All right? As you saw, the function I was showing you didn't actually do anything to the tree, so that's why we get this result. So we're not really surprised about this. So let's have a look at another example that actually does something. So we're going to update this function. Now we do a bit more interesting stuff, right? We take our tree and we call X number of invocations of the method create. So the create method takes two parameters, one being the file name and the other one being the file content. So we call that X number of times, and this means the end result will be that it will be creating files with some content inside of it. We actually believe in this schematic. We believe it will do something for us. And of course, in the meantime, when we work with schematics, it gets pretty boring to go into the terminal and say build and run and so on. I don't know what's up with this one. Maybe my ears are too small. All right, so we just add two commands here. One execute command, which runs npm run build, and the other one invokes our schematic. So that's going to make it easier for us. So we run npm run execute, which just builds and executes, right? End result being, yes, we actually did something. Because we are calling tree create X number of times. So end result here is a preview of what will happen if we run this for real. So it will create 4 different files with content inside of it. Okay. So we didn't actually create any files because we were inside of a sandboxed environment in the so-called dry run mode. So what we could be doing instead is just to shut that off. And the easiest way to shut it off is to set a flag here, dry run behind me, to false. So once we do that, we are in kind of scary land because we will actually do what we say we're going to do, which is in this case is to create files. But imagine that we run this and it deletes files. It might be a horror story, right? Because you might actually delete files upon your existing schematic project. So be careful when you run this for real. So for that reason, we have a separate command for this called execute prod. You run this again in the terminal and, well, it says create again and you don't see a difference. But that's when we return back to Visual Studio Code and we see that we actually have files created. So all of those files that we promised we would create, the fact that dry run was set to false, we suddenly have those files inside of our file directory. Okay, so we got 2 different modes. That's worth noting. And yes, we set the dry run to false, and that means we go live pretty much. So with the tree, we can do create, delete, rename, and overwrite. So we have different CRUD operations here available. Conscious of the time here, we can do different things when we run schematics. So for example, we can run it in a watch mode, which means every time we try to save a file, it's going to recompile. So that might be really neat when we are trying to develop a schematic. We can also be debugging this. It's very nice to have a breakpoint and be able to set that in VS Code, right? And once you run the schematic, it's going to stop. And you see, oh, this is what I'm doing. Because if you don't use this, you're going to resort to console log, and that's just painful, right? And yeah, so to test out your schematic in a safe way, I'm going to say safe way, because what I've been doing so far is not very safe, right? Because I've been running my schematic inside of my own schematic, so it's a bit of a, inception. That's not a good thing to do, especially if you run it in a sharp mode, right? In a dry run false, that's bad. Because as I say, you're going to pollute that space. You're going to add files or remove files or whatever you're trying to do. So you'd rather be developing out here, but run it out here. And when I say run it out here, I mean run it on an actual Angular project. So let's do that instead. So let's develop our schematic over here in a separate project, but run it on an actual Angular project. Okay, so what we do to make that possible is to do an npm link to the schematic, right? And once we're done with that, we can do an ngGenerate. So let's start by scaffolding an Angular project using a schematic, by the way. And then we do an npm link when we are at our schematic project. So npm link over here at the schematic project, scaffold the Angular project over here. Once inside of the Angular project, we run ngGenerate. And this time we're saying use our schematic with some argument, right? So whether we use this argument or not, well, it really depends on your implementation what that does, right? But the main point is develop schematic over here, scaffold the Angular project over here, and this is where you run your schematic. So end result here is that it's going to add those files to your Angular project, and it's not going to pollute the schematics project. So try to keep the two separate if you're doing this. Okay. So we're happy, right? It's time for a little victory dance. Bored yet? No? All right. Okay. So one really cool thing is the fact that we can use existing schematics, right? We can always write our own schematics, but that's going to take time. Sometimes we just want to augment or improve upon an existing schematic, and we can do that. You know why? Because the Angular team has something called a collection. So that means that the Angular team is actually releasing open source all the other schematics that you know. The one for component, for directives, and services, and so on. So every single command that you can run by Angular CLI, we can actually use those and augment those. So we can take an existing schematic that the Angular team wrote and say, well, when you're done with scaffolding your component, I want to add my ingredients to it, right? And that's what we're going to do here. So we talked about what a collection is. We said this is something the Angular team built, and they are maintaining it, and we're very thankful for that. So again, now we scaffold our own we scaffold our own schematic project. So once we do that, it's time for us to actually write some code, right? So I'm going to skip this a bit because I want to get to the interesting part. We're going to use a method here called external schematic. And this means that we are going to use the Angular team's own schematic. So we borrow this little method here, external schematic, from the SDK for the schematic and say, there's this external schematic that I want to use. So that thing doesn't live on the web, right? We still have to do an npm install to get it, but once it lives inside of node modules, we can use it by using this method external schematic. So what kind of sorcery is this? How can we be using some external schematic and add that to our own? Well, let's have a look at some code here, right? So one thing I want to do is add some disclaimer text. I said that, right? I want to be using the existing component schematic, but I want to add my own secret sauce to it, my own text. You with me? I'm talking in 200 kilometers per hour, and you're like, oh, slow down. Okay. So here we got an existing role, right? Our existing role in this case have already run the external command, which means we already have a set of files. We already have component TS, we have the component HTML, and the SAS file, and all those other files, right? So we've run the external schematic. That means we have a list of files that we can operate on. Once we have those list of files, we can iterate through each of these files. That's what this code does. So it yanks out the content from each of those generated files by a pre-existing schematic and just add our header text to it, right? That's cool. We can brand it, right? So once we do that, so we use the visit here as an iterator. So the visit iterates through each of all those created files, and the end result is, of course, we are running the component schematic, right? So the end results should still be a TS file, HTML file, a SAS file, and a test file. But there's a but here. We're going to get those files, as I said, but we're going to get those files with our disclaimer text. Doesn't look like much maybe, but it's pretty cool. We're a bit short on time, so I wanted to show you something cool. There are different examples here, so if I had a longer talk, I'd be able to show you everything, but I want to show you something badass. Can I say that? Badass? No. I said it twice now, so it's an established word. One really cool thing about schematics is the fact that we can actually look upon our existing code base. We can take an existing TS file and say, what is this code, right? So we use the TypeScript compiler and just analyze our existing code, and you know what the end result is? It's a tree. So what's cool about that? I take my existing TypeScript compiler and what? Well, if you take your existing TypeScript compiler upon an existing file, it will actually spit out a tree with different tokens. And those tokens has positions. And why is that interesting? Well, imagine that you want to add code or change code. You just need to know where, right? You need to know where do I add text, where do I remove text, where do I update text. That's the whole point. So here is an existing file. It looks pretty simple. But here we are using the TypeScript compiler. So the TS comes from the TypeScript library, right? So TS comes from the TypeScript library. To make this work, we use this TS and create a source file based on this demo file, right? The end result is a tree, as I said. And we can just write a very simple method like this that's going to recursively iterate through this tree and print everything out real nice. And the end result is this, right? So we are using the TypeScript compiler upon an existing code file. And we can almost read the code here if you know where to look, right? So it says you have something called class, demo class, brace, you got a constructor, and some parameters. This is too long to show everything on the screen, but I think you get the idea, right? You get a tree of nodes, and all of those nodes have a position. And once you know the position of a specific node, and you know where you want to add stuff, like a parameter or remove a code line, you just need to traverse this tree to the correct node and say, I want to affect you. 2 minutes. Okay, so how do we actually affect the tree? Well, we need to take this tree and flatten it into a node list. That's one of the first things we need to do. Once we do that, we find the correct position. Once we have the correct position, we need to create a so-called change object. So a change object is nothing more than an intention. It describes, here's the text I want to insert, here's the position at which I want to insert it, and then I'm going to hand this over to something that's going to commit this to the actual tree, right? It's not really complicated per se, but what we do first is get the nodes. Once we have this flattened node list, we're able to say, well, let's query and let's try to find that node that we care about. So for example, if you want to input a parameter in a constructor, you need to find the constructor node. Once you have that node, you can just go to its child list and say, here, I want to add a node here, right? But you're not actually going into a list and do a push, but you're rather saying, here's a position, right? Like an index. So once you've done that, once you located your correct node, you need to create a change object. And there are different types of change object: insert, change, update, change, delete, change, and so on. So all you need to tell it is essentially the text and the position, and then you hand it over, right? And then you do an apply changes. So apply changes is nothing more than a changes list for each loop that says, let's talk to something called a recorder. So a recorder is the one taking X number of changes and say, thank you for this insert, thank you for this update, thank you for this delete, and it ends with a commit update on the tree. So the tree say, I take a recorder as an argument, and I assume that the recorder has recorded X number of changes inside of it, right, for it to actually do something. And if we do everything together now, that we can see that what we're actually doing step by step here is we get our source from a certain URL. Once we have that source that represents a file, we can get X number of nodes, and we use the TypeScript compiler for that. And yes, we find a specific node that we care about. If we find that node, we find its position, right? The point of impact. Once we have the point of impact, we create a change where we say, well, insert this text at this position. We hand this over to this apply changes function that just say, give this to a recorder. Once the recorder is done, give this recorder to the tree, and the tree say this. Right? So that's 4 steps. And the end result of that is you being able to actually use a TypeScript compiler and write your own utility methods, right? Because Schematics is not perfect. It has a lot of utility methods that's going to help you with this, but in some cases, like add parameters or doing a bunch of code changes that it can't anticipate, you need to run your own methods. But as you see here, once you get the tree, once you get the nodes, once you locate the position in the tree in which you need to insert or delete, you're good, right? I've actually taught you how to use the TypeScript compiler. And yes, you're going to get these slides and you're going to be able to play this at normal speed. Without me being hyped on coffee, I mean. So further reading, Hans here from the Angular team who created Schematics, he has a very good entry-level post for this. Manfred Steyer, are you here? Somewhere. He has written no less than 5 articles on Schematics that's going to take you through this journey, everywhere from beginner to master, to my example. So read Manfred's articles and you're going to be able to use Schematics just like anybody else, right? And yes, as a summary, it's a workflow tool. It performs changes on a tree. And what you actually give to the tree are rules, right? And rules are nothing more than a change, right? You say, add a file, remove a file, insert code. It depends on what you want, right? It can be used for scaffolding files, as I showed you, but even more interesting, you could be updating code by affecting this tree that you get from the TypeScript compiler, right? Which is super cool. And it is the secret sauce behind the Angular CLI. Thank you, guys. Thank you for listening.